The generation of computers. Today, life has become indispensable without a computer. You find computerization in almost every sphere and industry. Computer evolution has been a fascinating process. The word computer comes from the word compute, which means to calculate. Thereby, a computer is an electronic device that can perform arithmetic operations at high speed. A computer is also called a data processor because it can store, process, and retrieve data whenever desired. The generation of computers may be broadly classified into 5 stages. Each generation is characterized by a major technological development that fundamentally changed the way computers operated. It provides a framework for the growth of computer industry. Originally, it was used to distinguish between various hardware technologies, but now it has been extended to include both hardware and software. Each of these generations overlaps with the other. However, these generations have been generally accepted classifications in the evolution of computer industry. The first generation, 1940 to 1956. The first generation of computers used vacuum tubes for circuitry and magnetic drums for memory. These computers were extremely large, taking up entire rooms. They were very complex and expensive to operate due to the great amount of electricity it required. Also, the computers generated a lot of heat, which was often the cause of malfunctions. These computers relied on machine language to perform operations. Machine language is the lowest level programming language understood by computers, and with this program, the computers could only solve one problem at a time. The first electronic computer was designed and built at the University of Pennsylvania based on the vacuum tube technology. Vacuum tubes were used to perform logic operations and to store data. The first general-purpose electronic computer was the ENIAC, Electronic Numerical Integrator and Computer. It was programmed using plug boards and switches, supporting input from IBM card reader and output to an IBM punch card. It took up 167 square meters of area, weighed 27 tons, and consumed 150 kilowatts of power. It used thousands of vacuum tubes, crystal diodes, relays, resistors, and capacitors. The first non-general purpose computer was ABC, Atanasoff Berry computer, and other similar computers of this era included EDVAC, EDSAC, German Z3, British Colossus computers, Leo, Harvard Mark I, and UNIVAC. The UNIVAC was the first commercial computer delivered to a business client, the US Census Bureau, in 1951. The second generation, 1956 to 1963. The second generation of computers used transistors. The transistors were invented in 1947 but did not see widespread use in computers until the late 1950s. With these transistors replacing vacuum tubes, computers became smaller, faster, cheaper, more energy efficient, and more reliable. Transistor computers were much smaller compared to the first generation, although still big by today's standards. These computers no longer used cryptic machine language, and they progressed to symbolic language. Symbolic language allowed programmers to specify instructions in words. High-level programming languages were also being developed at this time, such as early versions of COBOL and Fortran. These were also the first computers that stored their instructions in their memory, which moved from magnetic drum to magnetic core technology. The first transistor computer was created at the University of Manchester in 1953. The most popular of transistor computers was IBM 1401. IBM also created the first disk drive in 1956, the IBM 350 RAMAC. The first computers of this generation were developed for the atomic energy industry. Some of the examples of this generation are Honeywell 400, IBM 7030, EDEC 1604, and UNIVAC lock. The third generation, from 1964 to 1971. The third generation of computers began with the development of the integrated circuit. The invention of the integrated circuits, ICs, also known as microchips, paved the way for computers as we know them today. A single IC has many transistors, resistors, and capacitors built on a single thin slice of silicon. Making circuits out of single pieces of silicon, which is a semiconductor, allowed them to be much more smaller and more practical to produce. This also started the ongoing process of integrating an ever larger number of transistors onto a single microchip. During the 60s, microchips started making their way into computers. The process was gradual, and the second generation of computers still held on. Instead of punched cards and printouts, users interacted with third generation computers through keyboards and monitors and interfaced with an operating system which allowed the device to run many different applications at one time with a central program that monitored the memory. Computers for the first time became accessible to a mass audience because they were smaller and cheaper than their predecessors. IBM 360, PDP-8, PDP-11, CDC 6600 are typical of third generation computers. The fourth generation, from 1971 to 1989. With the invention of microprocessor in 1971, fourth generation of computer evolution started, and present-day computers are also categorized in the fourth generation. Thousands of integrated circuits were built onto a single silicon chip, popularly known as Very Large Scale Integration (VLSI). The Intel 4004 chip, developed in 1971, located all the components of computer from the central processing unit and memory to input and output controls onto a single chip. In 1981, IBM introduced the first computer for home users, and in 1984, Apple introduced the Macintosh. Microprocessors also moved out of the realm of desktop computers and into many areas of life as more and more everyday products began to use microprocessors. As these small computers became more powerful, they could be linked together to form networks, which eventually led to the development of the Internet. Fourth generation computers also saw the development of GUI, graphical user interface, the mouses, and handheld devices. Fourth generation of computers include IBM PCs, Apple Macs, VAX 9000, Gray 1 and 2, and Gray X/MP. The fifth generation, from 1990 to present and beyond. The early fifth-generation computers are characterized by ultra-large-scale integration, ULSI, RAID, and optical disks. Developers are working to design computers based on principles of artificial intelligence and natural language recognition. The use of parallel processing and superconductors is helping to make artificial intelligence a reality. Quantum computation and molecular and nanotechnology will radically change the face of computers in years to come. The goal of fifth-generation computing is to develop devices that respond to natural language input and are capable of learning and self-organization. The evolution of computer still continues.